boys, and welcome to today's lesson. I'm Mrs. Levine. Today, we will continue to investigate the question, how can we use observations as evidence to explain other forces? Are you ready? Grab your pencil and your science journal and let's get started. Hey, remember this video clip we saw of children playing a game with wooden figures? The last time we saw this video, we wondered how the wooden figures were able to move without being touched. Well, I'll give you a hint. The game pieces have magnets in them. I wonder if we can recreate this game using other materials. While I don't have a wooden game board like in the video clip, I do have a clipboard that we can use to represent the game board. I also have two magnets. One magnet represents the game piece, so I'll put it on one side of the clipboard. I'll put a second magnet on the other side. How can we use the magnets to recreate the motion of the wooden figures? What do you think? Oh, look at that! We can move the magnet on one side of the clipboard by moving the magnet on the other side. How does the interaction between the two magnets provide evidence of a force? Well, we observe the two magnets pulling together even though there is a clipboard between them. Also, when we push one magnet, the other magnet moves too. No other force is exerted on that other magnet to change its motion. So a force must have caused the interaction between the two magnets. You know, the interaction between the two magnets reminds me of the interaction station from our last lesson. We investigated the question, how does placing an object between two magnets affect the interaction between them? We saw that when we place a thin object between two magnets, the magnets are attracted to each other. But when we put a thick object between two magnets, the magnets aren't attracted to each other. Hey, this is an example of a cause and effect relationship. We can use our observations to help us write sentences using this sentence frame. When blank, then blank. The when part of the sentence will state the cause, and the then part of the sentence will state the effect. So how should we fill in the sentence frame for this observation? I think we should say, when a thick enough object is placed between two magnets, then the magnets no longer attract each other. Now we'll use what we observed from the other magnet stations to help us write sentences using this sentence frame. Are you ready? Let's revisit the magnetic object station, where we investigated the question, how do magnets interact with different objects? We placed a magnet near different objects and saw that the magnet attracted some metal objects but did not attract other objects. And we found that when we put the magnet near the clothespin, the magnet attracted the metal part of the clothespin but not the wooden part. Now let's fill out the cause and effect sentence frame for this station. I'll fill in the first blank. I'll write that when a magnet is brought close to certain metal objects. How would you complete this sentence? What was the effect of putting the magnet close to certain metal objects? How about when a magnet is brought close to certain metal objects, then the objects are attracted to the magnet? Is that what you said? Okay, let's move on to the orientation station, where we investigated the question, how does the orientation of a magnet affect its interaction with other magnets? Do you remember what we observed when like poles of magnets are placed near each other? When like poles of magnets are placed near each other, then the magnets repel each other. Now let's move on to the distance station, where we investigated the question, how does the distance between a magnet and a compass affect the movement of the compass needle? We moved the magnet along the number line. The compass needle didn't move when the magnet was farther away, but the needle did move when we brought the magnet closer. So for the cause, I'll write when a magnet is brought close to a compass needle, then what happens? What is the effect? Let's write that the compass needle points toward the magnet. Great! Just one more station left, the strength station. Remember when we explored the question, how many paper clips can different magnets hold? We placed paper clips on 3 different magnets to observe the strength of each magnet. We observed that when a magnet is stronger than another magnet, then how would you complete this sentence? Let's say, then it can hold more paper clips. Oh wow, we've identified a lot of cause and effect relationships between magnets and objects from the magnet stations. Do you think we can now answer the question, how can we use observations as evidence to explain other forces? I think we can. When you have your answer, shout it out. You may have said the magnets at the stations pushed or pulled other objects and changed their motion. Or maybe you said a force is a push or a pull. Magnets can push or pull each other and other objects. How is the force we explored at the magnet stations similar to or different from the forces we explored by using Atwood machines? What do you think? Well, the forces are different because Atwood machines require objects to be in contact in order to exert a force, but magnets don't need to touch objects to make them move. However, the force we observed at the magnet stations is similar to gravity because gravity also doesn't need to touch objects. The force exerted by the magnets is called magnetic force. Magnetic force is a force exerted by a magnet that can cause it to attract objects made from certain kinds of metal and attract or repel other magnets. Now we know that it's the magnetic force that attracts paperclips to magnets. Let's summarize what we learned about magnets and magnetic force. Through our investigations, we have learned that magnets have a north and a south pole. We also know that opposite poles attract each other and like poles repel each other. When a magnet attracts an object, the object is referred to as magnetic, and magnets must be close to magnetic objects to attract them. Lastly, we learned that magnets can attract with other magnets even when there is an object between them. Now, that's not all we've learned. At the magnetic object station, we also observed that magnets can exert a force when they are in contact with certain objects. At the distance station, we learned that magnets can exert a force over a distance or without contact. Let's add those two statements to our list. But wait, earlier in this lesson, we talked about how gravity and magnetic force are similar because they can both exert a force on an object without touching that object. I wonder, how is magnetic force different from gravity? What did we learn in our investigations that can help us answer this question? At the magnetic object station, we saw that magnetic force affects some objects but not others, while gravity is exerted on all objects on Earth. Let's add what we've learned about magnetic force to our anchor chart. What do you think we should add in this section? Let's say some objects can exert forces on each other without contact. These forces can cause objects to be attracted or repelled. Magnetic force is affected by the properties of objects and the distance between objects. Magnetic force is also affected by the orientation of magnets. After today's lesson, your first task will be to update the anchor chart. Let's end today's lesson with a mystery. I have a new video clip to show you. Pay attention to the water in this video clip. What do you notice about the water? I noticed that the water flows straight down into the sink because gravity pulls the water down. Now watch this. Whoa, the water bends toward the balloon. Now I have a lot of questions. What questions do you have after watching the bending water demonstration? For your second task, you'll write down your questions. Don't worry, we'll investigate the force that bends water in the next lesson, and we'll revisit our questions then. Let's review your tasks for today. First, fill in the blanks to update the anchor chart. Second, record the questions you have about the bending water demonstration.